Hey, hey, it's the 4th of March. It's my mom's birthday. So I just had a nice conversation with mom. Lots of family talk around here. Um, Happy birthday, mom. And now what are we doing? We're here for Aiken PBL. We meet on Tuesdays at 12:30 UTC. So if you're also, I'm paying attention to the calendar. I know that in the United States here, we're going to change our clocks this weekend. And so here's your twice annual reminder that if you change the clocks where you live, the time of this meeting is going to change for you. But we're going to stay pegged to UTC time. So next week, same time, same place, 12:30 UTC. Um, yeah, and so we've been doing a walk through the course, the Aiken PBL course, and Hinson and I built examples and wrote some lessons together. And this is kind of a fun place to kind of close out our lecture series. Jingles has been, or sorry, Hinson's been building with um, been building with Aiken on some production grade code, and you've learned some things not to do. So you prepared some examples to show us today.
Yep. Um, Let me share my screen. Here's it. So in previous Aiken PBL courses, I think we have covered most of the basic syntax about how to extract different information in scripts, and we know how to write basic validation. And it might be a good time for us to right now jump into look into some real world examples. So here we in the Mesh website, we could find that there are a bunch of different examples. So for here, we get into SDK and the smart contract lib. We will see a different sets of examples. These are indeed the smart contract that a lot of people just directly use out of the box. And when we click in one of them, for example, this spot, it is indeed the contract that could help us to perform the exchange of Cardano assets. So we will look into a few of these examples, look into how it is implemented, how they are good or bad, or even there are some examples on some selected contract that I've produced some example of bad contracts that talk about some common vulnerabilities. So this is a background. So before I jump right in, so I will give it a little pause here about yeah, if there's any questions from the forest or anything you want to learn about or what you want to kind of expect from these back contrast series. Yeah, all good, right? So if that's the case, let's just jump in. Can anyone see my VS Code, Visual Studio Code?
Yep, looks good.
Yeah. So this is indeed the mesh repository. So these we here on the website we have got the different contrasts. When we go into mesh packages and then mesh contract, we will find the source codes of different contrasts that we'll be covering in uh this sessions. So this is just a local clone of the mesh main repository. And when I check the contract, let me expand a little bit. You could see that their version, some of them having one version, some got two versions. And then for some of the contract folder, you will see that there is a special folder name, which is named by the common vulnerability that will pick a few to covers. So first of all, whenever we talk about Cardano contract development, there's one very, very famous vulnerability, which is this double satisfaction. So let's just jump right in talking into this vulnerability. So first of all, before we really talk about the vulnerability, let's take a look into the contrast that in the discussions. This is just a very simple swap contrast. So imagine there are two users, like one, for example, getting some Aethers. Another getting some USDM, for example, and one of them want to sell Aether for USDM. Another want to use the USDM to buy some Aethers. This is in this the basic of the DES logics. We could directly use this swap. So of course, this is just a very simple contrast. If you ever deploy a DES using this contract, you will literally get zero advantage against all of the major DESs in Cardano. But this is how it works. Like if you just want a very, very simple logic guarding the exchange of Cardano native assets value, this might be the one that you want to check out. Since we are in the Aiken PBL course, we might be able to directly jump into the contract code itself. So this is the implementation of the swap. In this swap, we can see that the source code is not that huge, actually. We have just got a like 20 something lines of code that could perform the logics. So before I really jump into the contract codes, anyone got any questions or got lost already or want to clarify with something?
It feels good to recognize all these patterns. Yeah, thanks for preparing this.
Yeah, since this is the first contract that we walk through today, I will also remind some of the basic syntax. So here we see that this validator, I give it a name called swap. And from the function signature, we could tell that this is a spending contract, which is a contract that we use to lock some value. And then we are expecting for different information in the inputs for this contract. So first of all, we got the expected datum format locked in this spending validator. So this is a swap datum. We take a look what's the information inside. So we got the initiator, like who's the one to initiate the swap, and we got the Cardano address. And then we've got two different information stored here also. One is called to provide, like when I'm doing a swap, I'm providing one SS value. Perhaps let's say I want to sell some Aether. So this to provide will be storing the Aether value. And in exchange, I want to get some value back, like for example, USDM. So this is the to receive value. So I've got one question here. Since if everyone just spot on when we look into the Aiken source code, we could find that there's indeed a value implementation in Aiken. Here. We've got a value implementation. So why I have to do a custom implementation of the value type rather but not rather just directly using the value out of the box from Aiken standard library. Anyone want to give it a try? Yeah, in standard library, we have get the exactly same type that we want to use here, which is value. Because from here, I self-implement a value type myself without directly using this standard library value. Any attempts?
And can you say the question one more time?
Yep. So from here, the source code of Aiken standard library, we have the value type, which is the Cardano value. Like for example, Aether or native token, how many of them? We could use this type to denote the value. This is the implementation. Why in the swap contract, I have to define my value type once again, but not directly using this one.
Maybe you want it to be a constructor and not like the Aiken one to be not a constructor.
Yeah, it's a nice attempt. But when you look into the type here, it's essentially identical, I could tell. Basically, it's identical, the information.
Then you want it to be possible 0.
Yeah, you are get very close to the actual answers. So, yep. Anyone want further attempts before I reveal the answer?
Maybe you don't want it to be opaque.
Yeah. Actually, these two answer combined together get very close to the reason behind. Yeah. Yep. So get back to the attempts that Adrian just gave, is that maybe I want to have a 0 integers. This is true. Like when I implement in this way, it is possible to have a 0 integer in the value. However, in the Aiken standard library implementation type, yeah, it will never contain a 0 value. And also some of the differences that in the standard library is using date as a type of the map. However, here I use the pairs. I didn't go into the details of these two, but in the actual implementation, they are essentially the same, the dictionary and the pairs. So what's the difference is that this dictionary from Icon Standard Library is very restrictive. Like there are some constraint into how it is implemented. For example, it has to be having a byte array, key types, and amongst other restrictions. And the pair is less restrictive. But comes into the actual reason is that if you remember the type, what does the type signature did? Is that we are expecting the datum come into locking in this spending validator is either to be none or is either to be this datum. And whenever there is some datum inside and we try to unlock from the spending validator, it will perform a auto deserializations. So it will try to fit into this type. So the problem is here. If we use directly the standard library value type, it got a chance that the validator before really evaluating the input, it will immediately sense that it got a chance that the datum cannot be passed into the value type. Another hint is that it is opaque, which means it is only for internal use only. Inside the Aiken syntax, it will not support the auto serialization or deserialization through the spending. So, in short, if you use the value type here, I remember your contract will either be cannot be compiled, or when you use it, it will never ever get into your contract body since the contract will just fail at this line. So these are the some of the details when you really implement a Aiken contract you might overlook. But we could also give it a try for now. Packages, contract, source, V2. Yeah, let's give it a try. State in theory, we might get lost very quickly. Just take a look. Yeah, for example, I directly use it here. Let's see if I could compile. I didn't really remember. Yeah. Let's say I just comment the logic for now. I just care about whether it could compile. Cool. We got quite a lot of things to be commented. Never mind. Let's do it. here's the answer. Here's the error. Like if you ever try to put an OP type into any of your datum or redeemer, it will be this error. Like it cannot be compiled. Like the OP type cannot be found in the validator datum or redeemer. Yeah. Obviously, the error message has been improved for quite a lot.
This
Yep.
is the
If you
latest
ever,
Aiken, right? They put out a message
yeah.
about improved errors. This looks really good.
Yep. So
Really
if you
good.
ever try to do this, it will happen like this.
But Hinson isn't the reason for that because it is not a constructor, so you cannot deconstruct it from the data type.
I think it has I think it has nothing to do with the if that is constructor, because theoretically in Aiken world for every datum type that you have implemented, it is possible to get into the constructor shape. So either do the same for the value type come out from the standard library in Aiken. But in their standard library, whenever they implement this opaque type, the compiler cannot generate the serialization and deserialization code by itself. So it just make the validator just cannot compile. So I think it's some of the design choice by the Aiken team, which to make sure that your contract is implemented safely. So make sure you don't put any very common that kind of type that could make your contract just fail totally. So it is, I would regard this as more of a safety measurement from the Aiken team. Yeah. I would just prefer this. No. Yeah. Or I just use this.
And
Yep.
could you repeat why, like, what is the reason for the safety? Like, why is it? Why have the Aiken team decided for the opaque, to be put there? And second one is like the what would be the reason for you to implement pair instead of dictionary?
Yeah. So I remember the reason behind is that since I forget which version is it. Dictionary itself become a opaque type itself, if I remember correctly. We could give it a quick fact check. Dictionary. Yeah. Now dictionary is a opaque type itself. And it is just nothing more than a pair type in the inner. So the inner syntax means that it will just pass through when you try to use it. So essentially this equals to this. So since I forgot which version of the upgrade, the Aiken team turned the key type of dictionary hard-coded to be byte array, but not allowing arbitrary data type for the key of the dictionary. Due to the I remember the release note, the Aiken team stated that due to everything could be theoretically be represented by byte array. Like even for other data type, you could just serialize it and then get the byte array, and then they move it into the dictionary. If you ever want to stay using some complex key types of a dictionary, you could just use a map instead. You could just use a pairs instead. There's the exact timing where the pairs has been introduced by the Aiken team. And what is your second question? I forgot.
I like why opaque still, like, because if we like if it's not an opaque object, then we can directly use it instead of defining it ourselves.
So here's the thing. I think the opaque type is just to try to make sure every operation in your contract is safely implemented. So for example, in the value type here in this some restriction that we know about the Cardano value. For example, it will never be negative. And if you just use the type itself, for example, here in the M value, it is possible for this integer to be negative. So whenever there's a negative value getting into the Aiken code base, there are a lot of different helper function on the value type. So some of these will be failing in the middle, like didn't perform correctly, completing the evaluation, but return a panic in between. So I guess the Aiken team is try to reduce this scenario, the chance of these scenarios from happening, like making sure every types are constructed correctly. Like for example, the value will never contain a negative value, etc. To make sure your codes are safe by using their helper functions. Yeah. Is it clear?
Yeah, thanks.
Yeah. So finally, let's get into this double satisfaction error. So we take a look into what's the contract has been implemented. So I won't go into all of the helper functions utility one by one again, or if you really get lost, just stop me anytime and I could dive deeper into these. But let's take a look into the contract. So first of all, when we get into the spending validator, aka the timing when we try to unlock some UTXO from the spending address, we firstly pass the datum. Here, this is a syntax that we expect there will be always some datum when we try to unlock. And then the user could supply either redeemers. So if you are the original initiator, you can supply the cancel redeemers. We'll just check whether your key has been signed in the transaction. Just check if you are the owner of the order, you could cancel the order. In the normal use case, like for example, the other person want to fulfill your orders, they could supply the swap redeemers. So if one want to swap with with you, the check it perform is that firstly try to locate the current inputs that is evaluating, and then we would check the own addresses. This is the spending validator address, and we see, whether there's only one input from the smart contract itself. If there is only one input, then we will pass the evaluation here, and then if no, it will return a false. And then other than that, we will check whether the proceed have been paid. Like for example, we are the initiator, we want to receive some value, and we make sure the aggregation value paid to my address is greater than or equals to this value I specify in the datum. And then from the order fulfiller's point of view, they want to get our tokens. So we will also get a check on whether the value paid to the current order matcher, if they could get the provided datum locker in the contracts. And then we track these three all together, the swap could be performed, just to making sure the original provided amount has been locked in the contract, and the matcher could get the token. And then when I was the one who provides some value in the contract, I could receive something. Yeah. So the vulnerability I want to talk about is indeed here. So if you're very straightforwardly want to implement the contract, you might just jump to check the settlement, like whether I have received the value I want to receive, and whether the order swapper has been receiving the value they want to receive. It is very straightforward, but let's take a look at what will happen if we skip this check. We get into the back contract part here. So from here, we've got a folder called double satisfaction. So let's take a look. Let's take a look. So in the README here, I've slightly described what will happen. So that double satisfaction is a case where imagine there are two UTXO locked in a contract, and then each of them specify some instruction. Like for example, using the same swap contracts as an example, I could provide 50 Ether in exchange for 50 USDM in one order. I lock in one UTXO. And then I got the second UTXO, which I provide 100 Ether. And I want to receive 100 USDM in return. And then when this contract will check whether the 50 USDM go into my address if the order got fulfilled. And the second UTXO will check whether 100 USDM has been sent to my address when this order is fulfilled. So what happened if there is a malicious player? Just give me 100 USDM in total. Is by the same time fulfilling this contract, this UTXO and this UTXO unlocking conditions. Like 100 USDM to me is fulfilling is greater than or equals to 50 USDM. And 100 USDM to me also fulfilling greater than or equals to 100 USDM to me. So in the single transaction, the malicious payer could unlock both orders UTXO by the same time and getting my 150 Ethers by just providing me 100 USDM, but not 150 USDM. So is there any question from here? Perhaps it's a little bit abstract, is it? So expand a little bit onto the example. It is literally just by commenting this field. When I not try to check whether there's only one input from the script, it will open up a vulnerability where when I try to create multiple orders in a disk, and someone could just fulfill both of them by providing less value to me. Take a look into this mock transaction. I am using mocktail to build a mock transaction in Aiken. So in this mock transaction, there are two orders. This is the first order. The first order, thing so smart. Never mind. I put the notes here. This is the first order. And then this is the second order. We've got two input UTXO from the contract. The first one, let me see. Yeah. The first one, I've got the swap datum. And then the second one, I've got the same swap datum. When we take a look into what's the swap datum, it's nothing more than just I provide 15 Ethers. This is the Ether, yeah, in a contract. I'm locking 15 Ether. And then in exchange, I want to get 1,000 unit of this test token. So these two are the identicals. So when these two orders are fulfilled, the expected behavior from me is I will just give away the 30 Ethers in total, and then I could get 2,000 test token. Is it clear here? Yeah. When we continue looking into this contract, in the swap test case, I will set this is only one input from script to be false. So essentially, these two lines will be run also. So this is how I produce the two inputs in the same transactions. This is simulating the malicious payer tried to unlock both of my orders at the same time. Meanwhile, in the TS out, there's only 1,000 unit of test token sent to me. And then this contract is passing. So this is the implementation that make me losing 1,000 test token in the trade. Yeah, so there's a complete walkthrough on what happened to a common double satisfaction with the top, if I would like to say, there's a top one vulnerability that newcomer Cardano contract, smart contract developer, or on-chain code developer will neglect and didn't take into account. So yeah, I will give a brief stop here and see any questions. Or comments, or what's your thoughts? And
Yeah, any aha moments for anybody?
yeah. All good, is it?
I would have a little comment. You
Yeah.
don't have to check for that it is just a simple script input, but you can also calculate how much input it is from that script.
Yep.
But sure, that adds a lot of complexity.
Yep. You're right. This is another approach to restrict the number of inputs. So we could use either way. I would say it's more of a habit. And a lot of the time in some depths, we also want to cater the case of there are multiple inputs unlocking. So yeah, it would goes into a area where the true complexity of different desks are actually about, like when you try to accommodate multiple unlock, like multiple fulfilling. Yeah. All good, is it? If it is all good, I think we got time to cover one more vulnerability. So the second vulnerability I want to talk about is another pretty famous vulnerability, but in my opinion, this is not as critical as the double satisfaction, where there will be actual value lost in the process. But this is also another very famous one. In the very early days, I remember some early projects were pointed out about not taking this into account, which is the insufficient state control. So give it a background. We know that, for example, this swap contract coming back into here, this is a spending validator. And whenever we implement a spending validators, these codes will just compile into a hash that is controlling this payment part. And when we remember in the Cardano world, every addresses got two parts. The first part will be the spending part, where it will control whether some of your value could be sent or not. And the second part will be the staking parts. Found this on the web. Which is controlling whether you could delegate into different stake pool operators, or even in the latest hard fork, we could even get some on-chain voting onto whether some value could be unlocked from the treasury. So when we get into a sequencer to take a look into the address, actually for the long form of a Cardano addresses where we use now is containing, you can see that there's two hashes here. First of all is the payment hash, another is the staking hash. And when we build Aiken spending contract, we will mostly compile the hash for this part Yep. So this is background information. So when we going back to our example, so what does it mean by the insufficient state control? So take a look. What is this marketplace contract doing? So marketplace is I would say the most popular contracts in the mesh repository right now. A lot of people just directly use this marketplace contract for their dApps. So for this marketplace, specifically is catering, selling some Cardano native token in exchange for Ether. And very specifically is mostly just selling 1 unit of a Cardano native assets. So put into context, for example, NFT marketplace could be using this marketplace. Like I provide my hotkey profile picture in the contract, and then I list it, and then I allow some other people to buy my hotkey profile pictures, and I could update the listing, like how many ADA I want to charge it, or I could cancel it. Essentially, it's very similar to what Swap can do, but it is particularly used for selling some native assets in unit of 1. So we take a look into what is the original implementation of the contract. Same, it is a spending validator, and we expect the marketplace datum. In the datum, I've specified who is selling the native assets. I determine the price, the ADA price or Lovelace price, because in the contract we usually denominate in the smaller unit, which is Lovelace. And then what is the current tokens that I'm selling? The token, the policy, and the token name. And the user can decide whether if I'm the owner, I could close the marketplace, which is similar to canceling the swap in the previous contract. And if I am another participant, I could choose to trigger the script, unlock the hotkey profile picture by buying it, aka paying me the money and then take my NFT away. Take a look into the implementations. Firstly, we expect there are some datums in the contracts. So when I am a user, is it when I am the lister, is essentially the identical logic with the swap. I just check whether the current transactions got my signature. If there's a third party get into my UTXO, want to unlock it and get my NFT out, firstly, I will check, try to locate my inputs, get the address, same to provide a double satisfaction, and check whether the NFT has been paid to the buyer, and then the proceed has been sent to me. The Lovelace and the price have been sent to me. Meanwhile, this contract is different to the swap, is that it will cater the fee collection logics. So in the parameter, I denote what is basis point of fees, which is basis point essentially is just percentage times 100. For example, 100 means 1% here. And we could check whether the handling fee has been sent to the developer, aka I'm the contract developer. I deploy a dApp, which is like JPEG store. I allow user to list the NFT, and then I could receive the payment. So this is these 3 are the only checks from the contracts, and this is a core logic of a marketplace. Yeah, any question about the contract logics and anything is very confusing that want me to clarify before going into the vulnerability itself? Yep, if there's not, let's take a look into how this is vulnerable to insufficient state control. So same, this is exactly the same implementation as the correct contract, except one very tiny detail, which is the datum. Oops, let me take a look. No, actually, the datum I'm using the same. I exposed the vulnerability by the check itself. So if you remember, if we use the get or value to or get or value from the Aiken from the vocal library, let's check from the source code. Cocktail. Yep. If we ever use a get or value to or a get or value from, we will try to accumulate all of the input value or output value to a specific address. So when we tell this is an address in Cardano, we know that going back into here, an address is something like this. An address is a data type that contains both the payment part and the staking part. Like if I am a developer, after I have written my Aiken code, I could compile the payment part. And then I could also control the stake itself by constructing the address by inputting my own staking part also. For here, I could either just providing the staking part that extracted from my internal wallet, which is a stake credential that I control 100% by my private key, or I could write another Aiken contract just to control the staking part to make sure there's no leaked voting power to the outsiders. However, if we're implementing a contract by not checking value to address, but just the payment part, this is where the vulnerability will be exposed. So from here, I coded the logic to, for the fee collection, I only check against whether value paid into the correct payment key hash, which will check, this is my owner key hash, and then I will check whether the fee payment is paid into an address having this pub key hash. So the scenario is this: if I am a malicious player, or I'm going to buy the NFT. So rather than paying the fee to me, to the address that 100% controlled by me, both the payment and the staking, I could pay into a address which is controlled by my payment part. But the staking part, it could just artificially compose one by inputting their own staking part. What is the cool thing of it is that after there are a lot of transactions gone through the marketplaces, is that perhaps is a very successful one, like JPEG Store. Like I collect millions of ADAs just from the transaction fee itself, like the fee collected by people using my marketplace. However, the address is not my it's not with my staking part. So the malicious player could help me to stake my ADA and then collect the staking reward from me. There are actually some of the value leaked by on one hand. On the other hand, some governance activities coming up, like for example, Project Catalyst, which we the most familiar with, or even in the latest hard fork, we could vote for different on-chain proposals. They could steal our voting power to vote for whatever they like. So this is implications. And in the unit test, I had prepared a very simple check, which is, yeah. So for example, my address, I don't have any staking part, or I have the staking part that controlled by me. The malicious player, if they want to send to a different address by same pub key hash, but having a different stake key. For example, this is the staking credentials that 100% owned by the malicious player's private key. They could do so. So for the test case, it is paid to malicious stake key. Like it composed another address, but not using our own address. And then this could pass. So yeah, this is another very famous example that is not hacking as your payment part, where you still control all of your aiders. Like you could just send to whatever address that you want. However, when you have values sitting in that composer address, people could just use your staking power for whatever means they want, stealing your staking rewards or helping you to vote for the proposal that you don't want to support, and so forth. Yep. So this is a entire walkthrough of another very, very common. I would say these two I choose to be walked through in the first session because these two are the kind of OG of common Cardano contract vulnerability. So yeah, following James' language, any aha moment for any one of you?
Is Mesh running Sequisitor now?
Yeah, this is a good side topic. This is the original Sequisitor, and right now the Mesh team we are actively migrating this into the Mesh cloud. So this is a work in progress. We will put in the Sequisitor somewhere in here with some improved nice UI and some transaction evaluation result also. Yeah. But this is where it were hosted originally.
Awesome.
Yep. So all of the contracts that I talked through, there are indeed live demos on the website here in the SDK and then contract. You try to run the code snippets and then look into the source code to learn something. And if you specifically want to check against the back contract logic, you have to get into the parallel folder in the source code. There will be walkthrough about how the vulnerability is exploited, and with a mod transaction that exploiting your contracts. So in reality, if you ever develop a dApps and then you find, for example, Anastasia Labs or M Labs to audit your contract, if they find a vulnerability, they will do something very, very similar, building some test case to show you how your contract could be hacked. And yeah, in the back contract example brought by Mesh, we have also done the same for a couple of different contracts. Not all of them got, but I feature the most common one. So in the section right now, the part one of the sections, where we will also have the part two next week, we have covered 2 out of 4 or 5. And in the next session, we will cover the rest. Yep. So I think for the course content wise, this is a wrap for today. And I hope all of you like it. And for sure, if you when you really try to play around it and got any questions afterwards, just feel free to DM me or just tag me, ping me in either Gimbalabs Discord or Mesh Discord. Yeah. And I pass the time back to James, perhaps.
Well, yeah, nothing
Or
else on the
we run some
agenda, but
discussion.
for anybody who's been working through the course content, learning Aiken, how did you find this session? Thought-provoking. Good. Does anybody have questions about anything else Aiken related? We've got a little time that we could use if there are questions.
Just curious, if this is going to be like what he went over is also going to be part of the Ondomio. I don't know if that was put in there or not. It's mentioned as far as like some of the do not do's.
Mm.
And bad practices, if that was going to be part of the Ondomio lesson for Aiken.
Yeah, this is not originally planned on the part of the scope of Aiken PBL, but there's indeed some activities from the Mesh team itself. Like in Mesh, we have one initiative to implement some of the standard contracts and also come with some back contrast example. And after talking to James and Jingles, we found that this is a very nice occasion to just combine the walkthrough of the back contract in the cloud of Aiken PBL students, since yeah, like this high synergy, like the same Aiken codes and the patterns that we have been talking through in this process, and it will be a kind of a nice kind of wrap in the kind of later part of the course. But when we talk about whether to add this into the Endamio content, I think this is most of the James core. If you want to add it, for sure, we could add it into here also.
Yeah, I think this video is great as a place to start. And Hinson, you had some ideas down here about just general architecture. But what do you think? I mean, one way to show people a deeper dive is to think about architecture. And another way is to show patterns and to work through those one at a time, kind of like we just did. How would people rather learn? Yeah, would you rather be shown like a framework for building an app before or after seeing some of the examples that Hinson just showed?
Just a personal opinion, but I think it's better to first show the architecture because then you have a better picture of the whole stuff.
And maybe we could just replace topics we didn't cover with bad ideas. What if we just do that?
Yep, I think that's sounds good also. Like as an additional information you could check after everything.
What's today, the 4th?
Yeah. The same for the, but however, for the course perspective, I think we prefer to stick to having the part 2 of the back contract next week. Just
Yeah.
don't cutting through the stuff. And then after that, me and James will find a day to deliver the architecture for the dApps.
This is good general purpose, and this really points towards the like general Cardano dev onboarding course that you've been designing as well.
Yep.
Cool.
The true learning story for me is something like best practices or that contrast. It has to be repeatedly keep it mentioning and refreshing the memories so that you know it by heart by the time of implementing contract. So yeah, perhaps that feedback was taken and noted. For the next week's part 2 of the back contract, I will try to deliver in a more high level the kind of perspective, because maybe in details when we want to look into the back contrast in details more in the Aiken PBL learning perspective, it might become after the architecture depths. Maybe we could also find a time to revisit this stuff. Yeah.
Yeah, this can be an ongoing thing. We might even do something like this session quarterly or something to keep it fresh in people's mind. And there's always new vulnerabilities that people will discover. When it comes to credentials for this course, I wanted to take a look. So like, here's the example. Here's the first assignment. And what we're able to do now is let's put the first of these credentials on chain just so people can start working towards this. I know that over at Gimbalabs, and then in Mesh, as you guys are building the team, we want to start using credentials that people earn by working through these courses to unlock access to contribution. And so we should be now at a point where I can, that's the right wallet. Yeah, let's just put this one up, right? Like getting started, we want people to set up their dev environment, write some tests, and print a trace message. Oops. I'm just going to add punctuation to each of these guys. Working with tests, that looks good. But the way it works is now we can publish this, and this is what it'll mean to have an earnable credential. Let's do it. This one's going to go on chain. And yeah, we'll talk more. We're kind of soft launching on Damio as we continue to roll out courses. But this one's a pretty important one. And I know that some of these modules might be prerequisites for the Asteria project, for example. All right, so now people can go in and they can do this assignment, right? And you can actually earn this credential. And we just have to think about what do we want people to submit here? What if we say share a screenshot of share the screenshot of the results of a new test. I'm struggling with words right now. So we're asking people basically to try creating some custom types and test that shows equivalency between two types. And we can always change this. I'm curious how people will do with this. So what if we start there? And I'm curious how people will feel sharing screenshots in the UI. So yeah, that's what we can do to start. And now when you log in, if you're enrolled in the course and you connect a wallet, you'll be able to submit evidence down here. We'll see how that goes. And we'll continue publishing the assignments over the next week or so. But just in case people want a place to start, feel free to jump in. And if you have questions, don't hesitate to ask them in the Gimbalabs Discord. I think we can close out there for the day. Scott has a question. How much variance in the bash prompts? Oh, yeah. I mean, don't worry about having any custom prompt, right? Like that's I know that one of the things we try to pay attention to when giving you bash commands to cut and paste is when people are new to that. Sometimes they get tripped up because they copy the prompt symbol as well. I'm not sure what the best practices are for that, but I think I think it's worth it to trust people to figure that out, right? And every dev who copies and pastes documentation has been through that experience of, oh shit, I'm copying the bash prompt. Um, that's good. Well, if there's no further questions, we can close out here for today. Thanks for the lecture, Hinson. And thanks for hanging out, everybody.
Yeah, thanks for hosting.
Yep. All right. Hey, if you're watching this video, you can find us at 12:30 UTC on Tuesdays. The link to this call is at gimbalabs.com/calendar, and it's posted weekly in the Gimbalabs Discord. Hope to see everybody soon. Thanks, y'all.